Hi, everybody, and welcome to our first independent weather investigation of the quarter. So before I jump in, let me tell you what the purpose of these independent weather investigations is. So this class is a 5-unit class, meaning that at least in terms of lecture, it's different for labs, but in terms of lecture, we are supposed to meet 5 hours a week. Now, that being said, one of the pieces of feedback I got from students pretty often was that 2.5 hour lectures was a lot. And I understand that. I feel that. I used to offer this class 50 minutes a day, every day, but then nobody signed up for that. So it's kind of a balancing act that I've done. Just transparency behind that. So what I did is I instead made this class an 80-20 hybrid class. And what that means is that 4 hours a week, we are meeting as a class, we're doing Zoom lectures, doing the stuff that you would do in a typical synchronous class. But then the last hour, that fifth hour, you would be doing an investigation, an activity by yourself, on your own. That being said, I do provide demos and explain what you need to do, so I'm not just throwing you in the deep end. So that's the purpose of these. This is just a way to shave off an hour from the week so that you can kind of have a little bit more flexibility in your schedule. This is the first time I've done it like this, so I'm interested in getting feedback at the end of the quarter, how it went, and should I do this again? Should I tweak it in the future? That being said, let's jump into today's independent weather investigation. Let me move over to the PowerPoint that I'm using for this. And I'm going to go through this really fast, mostly because it's mostly images, and I don't want to take up a lot of your time. Excuse me. So, what we are talking about in this independent weather investigation are weather maps. I'm sure you have seen at least one point in your life some kind of weather map, either a radar map on your phone or a temperature map in the newspaper. Like, I know who reads the newspaper anymore. And so what I'm really trying to do for this investigation is just sort of orient you, give you an introduction to reading a basic weather map. So first I wanted to say a few things about weather maps. So first off, the purpose of a weather map is to allow us to look at weather conditions over a large area. And if you recall from what we talked about in class on Wednesday, weather specifically talks about the different conditions of the atmosphere. So things like air temperature, dew point, cloud cover, rainfall, all of those different things are components of a location's weather. And what a weather map does is it allows us to view each of those components and how they are distributed over a large area. Usually here in the United States, it would be a map of the United States. The benefit of using one of these large-scale weather maps is they allow us to identify patterns. So is there a big storm system barreling across the country? That is useful for helping us make future predictions. So if we see that there's a big storm system on the west coast of the United States, and we're able to track its ability by looking at a few different weather maps, we can then make predictions on where it's going to go. So weather maps actually do have a lot of power in them, and they actually are a very useful tool that meteorologists use to make future predictions. Weather maps can display one variable or many variables. Some of the maps I'll show you in a few moments will display only one thing, and then others will display many things. And there's benefits and drawbacks to each of them. So let me show you what I'm talking about here. So this is a weather map of just air temperature. And there's two things you see here. First, you see a bunch of numbers. Those represent the numerical values of air temperatures, but you also notice these color codings. These color codings are actually different categories of air temperature. So for example, where you see the oranges down here, these typically represent temperatures in the 80s. Where you see this green up here, this represents temperatures in the 40s. And so this helps you get a large scale view of how air temperature is distributed across the whole United States. And pretty quickly you can identify, okay, the warmest temperatures are down here in the Southwest and then down here in the Southeast. The coldest temperatures are up here near Illinois, Arkansas, Wisconsin, Michigan, and then up here in the extreme northeast of the United States, up near Maine, Vermont, New Hampshire, and so on. That's not the only thing that we can put on a weather map. We can also include things such as storm systems, high pressure systems, that's those big blue H's, low pressure systems, those are those red L's, and then these weird looking lines with spikes on them represent frontal systems. I'm not going to go into detail right now as to which frontal systems these are, but I will actually show that in a later class in this course. So, but these are actually weather makers. So we actually care about their positions. Here's a map, I took this one from the American Meteorological Society, of air pressure. And these lines called isobars help you actually identify where higher pressure is located and where lower pressure is located. Again, don't look at this and get scared. We will actually go through this more in detail later in this class. So you're going to be totally fine. Another variable that we oftentimes look at is what's called dew point temperature. This actually tells us how much moisture is in the air. When explained very simply, it pretty much tells us how much moisture is in the air. This map provides wind speeds in these different blue shadings. The darker the blue, the faster the wind speeds. And then these numbers over here represent gusts, how windy it is, or how windy those gusts become. Here's another map very similar to that other map I showed earlier that included fronts, storms, and then you notice a lot of these weird, irregularly shaped greenish with some yellow speckled in there. That actually represents rainfall. So wherever you see that green speckled in there or that little yellow spots, those actually represent rain. So in that region, so right up here in the Texas Panhandle, for example, it's raining there. Down here along the Texas-Mexico border, it's also raining. Meanwhile, over here in California, high and dry. We can actually take away the fronts and just focus on the precipitation itself. That's another map we can look at. We can even zoom out, and instead of looking at the actual precipitation, we can also look at cloud cover, where clouds are located. This is actually helpful for us because this can help us identify where organized storm systems are. There's a nice big swirl of clouds right here. This was likely a tropical storm. There looks to be a nice little frontal system right here, a nice little storm right there. There's another big batch of clouds there. If we actually go back and we look, it's a giant front down here associated with that rainfall. This rainfall up here might be related to more summertime rainfall. There's other factors that go into it though. Now that being said, as a meteorologist, if I'm sitting there and I'm trying to make a weather forecast, I don't want to have to flip between 80 different maps. That's way too much work for a meteorologist. So instead, what we oftentimes do is we abbreviate things. Just like how Deanza loves to abbreviate things, like MLC for Media Learning Center, the S buildings for science, the L buildings for language, all the different abbreviations that are used, we do the same thing as meteorologists. We oftentimes take all of the information that we can and we condense it onto, I know this looks overwhelming, but actually relatively easy to read symbols called station models. Actually focus on one of these right now. Sorry, my mouse is very sensitive. Even the slightest inkling of a click and it changes. So let's focus on that one right there. There's a lot of information provided in just this one single set of symbols. And what you see here is in the center, you see a circle. In the left-hand side, on the left-hand side, you see two numbers, one on top, one on the bottom. Then out of the circle, you see a stick, and at the end of the stick, there's another little, what's called a feather. Then the circle itself is filled with something. And then in the upper right-hand corner, there's another 3-digit number. Now, I know what you're thinking. Holy crap, Terrence, maybe I signed up for too much. I need to go and drop. Hey, this still isn't as bad as physics, I promise. That being said, let's actually decode this and demystify this. And once you get the hang of this, it's like riding a bike. It's not that bad. I promise, just hang with me. What this is called is a station model. Basically, it takes all the different weather conditions that you would want to look at, and it condenses them into a pretty compact symbol that you can then decode to discover all of the weather conditions. Okay, well, how do we read this? Well, actually, it's not that hard. Let me show you. So the upper left-hand number right here represents air temperature. So that upper left-hand number represents air temperature. The lower left-hand number represents dew point temperature. The shading in the circle actually tells us cloud cover. Cloud cover. The stick, that long pointy stick that's sticking out, actually tells us wind direction. The thing that's pointing on the end of it actually mentions wind speed. And then finally, this number right here, this 221, this actually represents pressure. This represents air pressure. Now, in the next few slides, I actually have a nice detailed legend that shows you how to do these. So if I were to decode this one station model, air temperature, that upper left-hand number is 55 degrees Fahrenheit. The lower left-hand number is dew point. That is 53 degrees Fahrenheit. The circle itself is fully shaded. That actually represents 100% cloud cover, so it's fully cloudy. The stick, so let me redraw the stick. It looked, I'll shade this in real quick just for consistency's sake. It was pointing up and to the left, and at the end of it, it had a long line. So what this actually tells us, the long pole itself tells us the wind direction. And it works just like a compass. Just really quickly, this map is going to be consistent with any map I give you in this class. I'm never going to trick you with this. North will always be on the top. South will always be on the bottom. West will always be on the left. East will always be on the right. When you see this line pointing up and to the right, that represents, that represents a wind direction coming from, coming from the northeast. So on this map, winds are coming from the north and east. So they're coming from the northeast. Okay, now what about that thing sticking out of the end of it? That thing sticking out of the end of it represents wind speed in nautical miles per hour. I'm not, you don't have to worry about how to convert nautical miles per hour to actual miles per hour. You just take it and multiply it by, or to convert knots to actual miles per hour, you take whatever your number is, divide it by 1.15. I'm never going to ask you to do that. That being said, here's how you read that stick. And I'll actually draw it up here. So for wind speed, here's the long stick that is sticking out of the circle. Whenever you see a little half tick that's not quite at the end of the pole, it's not quite at the top of the pole, that represents 5 knots. So let me find a city here with the wind is 5 knots. This city right here. I think that's Billings in Montana. Don't hold me to that. I don't have every city memorized. They have a wind speed of 5 knots. Whenever you see a long feather sticking out of the top, the edge of the pole, that represents 10 knots. Sometimes the winds will be so fast that we actually need a bigger symbol. So what we'll use is this right here. That represents 50 knots. And what you'll notice sometimes when looking at some of these locations, you may notice a combination of these different feathers. So for example, Denver, Colorado, right here. You notice one long feather and one short feather. You add them. So that would give you at Denver, Colorado, a wind speed of 15 knots. And then finally, sometimes there's no wind blowing. In that case, surrounding our circle, you will see a second circle. So let me draw that. And let's say the circle inside is, I don't know, 40% cloudy. This would represent calm. Sometimes the inside may be perfectly clear. That's just cloud cover. But this outer circle wrapping around it would be calm. So for example, Seattle up here has an extra circle surrounding the inner circle. That's calm. Reno, Nevada, down here, has the same thing, an inner circle with an outer circle instead of the pole. That's calm. Down here, Phoenix, Arizona, the inner circle with a little bit of cloud cover, and then the outer circle, that represents calm as well. So for our city right here, I redrew it. So wind speed is just one long pole at the end. That is 10 knots. And then the final thing. In the upper right-hand corner, you will see a 3-digit number. That 3-digit number represents air pressure. So that 3-digit number represents air pressure. Unfortunately, it's not that simple. Air pressure is oftentimes a pretty big, long number. Average sea level pressure is, and I'll just write that here, 1,013.25 millibars. 1,013.25 millibars. All right. So that's average sea level pressure. To put that on each one of these things would make it too big. It would take up too much space. Look at how much space each one's taking up already. We don't like that. We don't want to go home and write about that. So instead, we condense it down to 3 digits. Down here, this city that we were looking at, this is Amarillo, Texas. The 3-digit number was 221. How do we convert that to an actual air pressure? Well, here's what we do. What we do is we do a 2-step process. Step 1. Step 1. If our 3-digit number is less than 500, we stick a 10 in front. We stick a 10 in front. We stick a 10 in front. So if the number is less than 500, we stick a 10 in front. In this case, our 221 is less than 500. So what we would actually do is we would go 10221. So that's our first step. If greater than 500 or equal to 500, if the number is greater or equal to 500, we stick a 9 in front. If you're explaining this to a friend, to a classmate, make sure that you use the word stick or put in front. Don't use the word add, because a lot of times when people hear add a 10, they think add, like plus 10. That's why I use that word stick. You stick a 10 in front. You put a 9 in front. So let's say I had a number like 789. What I would do is I would put a 9 in front. So that's the first step. If it's less than 500, you stick a 10 in front. Greater than 500, you stick a 9 in front. Step 2, whatever the number you come up with is, you put a decimal between, oh gosh, sorry everybody, last two digits. You put a decimal in between the last 2 digits. So for example, 10221, I would actually put a decimal, 10221, put a decimal right there. So it would be 1,022.1 millibars. For my 9789, I would put 978.9 millibars. Sorry that my pen is acting up. That is horrible penmanship. But I at least hope that I'm explaining it well enough for it to make sense. So in this case, to convert that 3-digit number to a 5-digit number, if it's less than 500, you stick a 10 in front. If it's greater than 500, greater or equal to 500, you stick a 9 in front. The next thing you do is you place a decimal between the last two. So you place it between those last 2 digits. All right, that's really the bulk of what I have to talk about. I do have a little legend. I will actually put this in the presentation. I'm actually going to upload this presentation as a PDF, so you'll have it. And it also explains how to do the air pressure. And then there's also some useful symbols right here that you may encounter in this activity. The only thing that's a little ambiguous, haze usually just looks like a normal infinity sign. And then this right here is the map that you're going to be working with. So actually this map is 1 hour later than what you're going to be working with. But I have selected 4 cities: City A, City B, City C, and City D. And you are going to then select which one you're going to be using. Or you're going to then answer questions based off which one you're going to be using. All right, so that's everything for this. If you have any questions, comments, concerns, and or threats, please don't hesitate to drop me a line. All right? Good luck, and bye. I gotta remember to hit stop recording, and bye.